Hello everyone. In today's session we'll be talking about the survey drafting techniques. In this session we will lay the foundation, very important information for all the civil design information and skills that we'll be learning down the track, either for road design or new subdivisions, new developments, rural road design or urban road designs. So in today's session we will start talking about some important information. For example, if I will be asking you down the track to give me the offset longitudinal alignments at a chainage of 3600, for example. What does that mean? We'll be talking about if I'll ask you for the bearing of the boundaries for a parcel design. Also, we'll be talking about if I'll ask you to give me the length of a pipe, underground pipe for infrastructure design on a road plan. How can we scale that and give me the accurate length for this pipe? We will talk about some important information, so it's great if you can pay attention to this information. We will use them a lot down the track. So as we agreed and discussed before, the purpose of this study is to interpret and understand the survey data, is to learn the important information. I wouldn't say the basics, advanced information, not to a professional level. As you know, everything will take time to learn. Road designs they tend to be a bit complicated down the track. So we will learn a great deal of road design techniques and information. Also, we'll learn the important skills and information for subdivision and new developments. We'll try to utilize the advanced technology, mainly the software, for most of the information. Having said that, in most of those information, before we start using the software, we have to have a great understanding, in-depth understanding of the information to be able to utilize it correctly on the software. So the software, let's keep in mind, it's a tool only. Without having the depth of understanding behind the tool, you will not be able to interpret the information correctly on the software. The same as we discussed in structural drafting, what you learned in structural drafting, the same what we discussed we've got specific information there. For example, what's the meaning of a UC or a UB, universal column or universal beam, a hunch connection, a moment and rigid connections, the edge distance, the same exact thing. We've got foundation to lay in civil design, and that's what we'll be doing in today's session. Before I start, I've got two groups of videos. Mainly it's for you to watch on your own time. They're just for you to, the first group here shows you the process usually we do for most of civil construction. So civil construction, generally speaking, is more expensive comparing to structural construction or structural work. The reason is usually civil construction involves large areas. Road design may extend to kilometers. Pavement areas usually are larger areas, and they use lots of material. Lots of machinery will be involved, you will see in the videos, and they take longer time. Therefore, and it involves stopping of the traffic, lots of other parameters, and working in an uncontrolled environment on the road most of the time. So it's very costly operation to be carried out. Therefore, the first two group of videos just to show you the scale of the work and to show you the importance of the accuracy of your work. Mistakes with civil design, usually they are costly mistakes, so let's try to avoid them and always consult with your supervisor. Number two, mistakes in design. I'm not talking about minor mistakes, I'm talking about in fundamental mistakes. If we carry out if the design engineer, which is mainly will not be involving you in the associate's degree as an undergraduate certificate or in the associate's degree design students or professional down the track, But regardless, as a team, if mistakes, fundamental mistakes in the design was to happen, therefore great consequences will be there. Okay, so the first one showing you a flooded road just to the lack of the consideration for drainage under the road and the estimation of hydrology design parameters. The second one will show you another type of mistakes which could be involved in the actual road design. We'll be talking about these two a bit more down the track. What are the parameters that we have to keep an eye on so we avoid these mistakes? Having said that, I thought it's a great idea before we start anything, so we have a better scale of the issues or the consequences of mistakes so we can avoid them. The points that we will be discussing in today's session: working with scales, very important. So working scales and scaling existing plans, or reading measurements of the plans, or drawing a new item on an existing plans that's been measured on site. So how can we interpret the scale on the plan and scale down the length of a pipe, for example, or the length of a fence or retaining wall? How can we scale it correctly so we can place it correctly on the plans? Or the other way around, if we have an item on the plans like a retaining wall or pipe, and we need to mark or set up this on site, how can we scale it correctly and obtain the right scales and length? Bearing, very important concept that we need to learn. It's new to most of you. The concept of bearing, which is the direction, the survey direction, let's call it, provide us a clear and precise information about the direction between 2 points, or the location of a second point starting from an existing point or a known point. That will lead us to two important concepts, which is the polar coordinates and the rectangular coordinates. Two different ways of describing location of points. Points are very important. When I'm saying points, guys, I'm talking about survey points. Survey points, you name it. They specify, for example, the starting point of a road and the end point of a road, or a location on a surface, a particular point on a surface, as we discussed before. It's made of a group of points. So each one of these points, they've got certain locations. So it's very important to learn how to obtain and interpret and read these locations. So we've got two different methods: the polar coordinates and the rectangular coordinates. That will lead us at the end for traverses and the drawing of boundaries, parcels, what we call them, or road traverses, open traverses, what we call them. So we'll talk about those as we get to them one by one. The first thing I'll be talking about, and I'm not going to complicate things, just the scales. So we are all familiar with scales to a certain extent. When I'm saying about scale, when I'm saying scales, I'm referring to plans scales or the ruler scale that you use. As we agreed, we will learn both ways: manually, how to measure an item on the plans and scale it on site, or how to draw a known item on site, say a retaining wall, on the plans. This is one, manually. Number two, I'll show you how do we do it on the computer too, using the Civil 3D or the AutoCAD software. So to start with the basics, scales usually are defined in two different forms. You've seen them before as 1 to 100 or as a fraction, as 1 over 100. And both, they give the same meaning. That means each 1 unit on the drawing represents 100 units on the ground. Very simple, okay? Now, scales, they vary. We've got many different scales: 1 to 100, 1 to 200, 1 to 500, 1 to 1000. These are the 1 to 2500, 1 to 5000. These are the main common scales. Having said that, we've got 1 to 300, 1 to 400 if we have to, other scales for different items that we can use. The important part for us here, to start with, that we are familiar that the scale of the drawing usually is shown on the drawing. If a scale in this form representing the actual scale of the drawing is not shown there, usually a scale bar will be shown there. Let me show you an example, and you have this on your TAFE page. So to start with, this is our section for today. This is the lecture slides. We've got two files, one for the tutorial and the other one for the solution of the tutorial. So after you finish, you can check your answers and make sure that you've done them correctly. And I've got some road intersection example drawing. So if I look at that, for example, just by looking at this, this is just showing a road intersection. Before I get to this, that brought me to another point. Why are we studying scales? Civil drawings in particular, they tend to have many different drawings. For example, this is a group of plans for road design. They've got, as you can see, we've got many different drawings in many different scales. The first one showing the overall view of the road that we are looking into, and we're looking for making some changes or designing. Title drawings. Cross sections. Cross sections, they usually 1 to 100, 1 to 50, 1 to 200, depends on the scale of the cross section. So they have different scales. These are the road cross sections. Scrolling down, this is the alignment when we talked about the alignments before. So when we say the road alignment, the horizontal alignment, this is showing just as one line what is the road made of, what are the areas that we need to work on, and we've got some comments here. Okay, again, the alignment with different information. I'm not going to great details into those, so I'll use this as an example, which is you have this layout on your Learn page. Now, as we agreed, because we've got different plans with different size of the consideration on that plan, or the point of focus on that plan, you can see here one view looking at the entire road, and then I've got, look how many sheets here. Each one of those is a different sheet looking at that particular part of the road. So each one of these sheets showing just a small section of the road, like this one here, the intersection, for example. And obviously the scale of this drawing will be different than the scale of that drawing. Therefore, it's important for us to understand scales. This is number one. Number two, as we agreed, drawings, they usually have a scale specified on the plan, similar to what I showed you here in a text form showing you the exact scale of the drawing, or it could be just as a scale bar like this. That's showing you, if you measure from here to there, that should be 150 millimeter. That will help you to take any measurement on this plan and compare it to that measurement, and you'll be able to get the length. As you can see, that measurement here is 150 meters, whereas on this plan, that exact measurement is 10 meters only. So that's why scales is very important for us to understand and to be able to work with them freely and comfortably. Going back here, so we agreed the scale will be either specified on the plan on a text form like this, or will be specified in a bar scale form. Now let's get into how to work with scales. So when we're saying 1 to 100, that means, as we agreed, 1 unit on the drawing will represent 100 units on the plan. So if, for example, I've got two examples here. If I've got the scale is 1 to 200 and the ground measurement is 2 meters, how much should that be on the plan? So what you have to do, simply, first of all, so we can keep the units uniformed, convert this number into millimeters, divide it by the scale. In fact, it's multiplying it by the scale, but dividing by the large number. So let me write it down for you. So the 2 meters will turn into 2000 by converting it to millimeters. times the scale that we have, 1 divided by 200. That will give us 10. So all we did, we multiplied by the scale. We divided by the scale number. Please do not be confused. The actual scale is 1 to 200. That's your scale. We multiplied by that, 2000, multiplied by that, but in practicality, we divided by the scale number, okay? I don't want you to memorize it that we're dividing by the scale number because things will be a bit more complicated in a minute. But generally speaking, this is as a starting point. Do not dig too much into this. Let's move on to the next point, and that will give you a clearer idea on how to deal with these numbers. Examples of the scales, as we agreed, 1 to 1, 1 to 100, 20. 1 to 20 is another important scale. By the way, these scales, some of these scales, you'll be using them in structure drafting too. Okay? The smaller scales, generally speaking. So any of these larger scales, 1 to 500 and above, we can go 1 to 5,000. All of those, the larger the scale, that means the larger the site we're dealing with. Because in structural drafting we're dealing usually in a smaller components, sometimes in some details for connections, sometimes in a just of a roof plan, for example, for the warehouse we're working on. Usually we tend to use with maximum 1 to 200, okay? Anything more than 200 usually goes into larger projects, and most likely that would be civil projects comparing to structural projects. Anyways, going back here, another example here, the same exact thing we did. If I have 28 meters on site, multiplying it by the scale or dividing by the scale number, that will give us the value. Let's have a better look at it, because things usually they get a bit more complicated. In other words, not all scales, when you measure things, so where are we heading with this? Let's say all what we know now, we have plans, and these plans, they have a scale. For example, in this example here, we have 1 to 200. Okay, it could be 1 to 500, any other scale, doesn't matter. Let's use the 1 to 500, so you don't think that all scales are 1 to 200. So let's say the drawing scale is 1 to 500. And I need to measure an item on the plan using my ruler. Now, rulers, not all the time exactly the same, especially engineering rulers. They've got different scales on them, as you can see. These 1 to 20, 1 to 200. Great if we can find a ruler has the same scale as our drawing. That means wherever you measure here, that will be exactly on the plan. Okay? So if the ruler scale here exactly the same as your drawing scale, that means wherever you measure here, so if I measure that distance on the plan of 1 to 20, that means it's 50 meters straight away. Okay? Now, that's not always the case. Usually the plan will be different scale comparing to the ruler what you've got, and not everyone has these rulers here. Okay? So how do we work with this? It's very simple rule. There we go, we've got it here, and that will be it for now. So this is the important rule. That's why I was saying a minute ago, do not worry too much about the previous. Change the color if I could. There we go. That's why I was saying previously, do not look at that rule. Let's focus on this particular rule here. This is our rule. This rule is saying the length on the drawing equals to the actual length on site. This is on site, divided by a scaling factor. Scaling factor will come from a component of two different scales. The scaling factor equals to the scale of your ruler divided by the scale of the drawing. When I say the scale, not the scale number, it's the actual scale. So if your ruler is 1 to 20, I'll put here 1 on 20. And let's say the drawing scale is 1 to 200, 1 to 500, I'll put here 1 to 500. That's your scale. Okay? These two here will form one thing, we call it scaling factor. Therefore, our actual drawing divided by the scaling factor will give us what the drawing should be, what the length should be on the drawing. Let's take an example so we don't complicate things. Let's go back to, ignore all of that. Let's go back to this. Let's say someone called you and said, well, could you please measure this, let's take another distance, this distance for me on the plan, because we've got an issue on site. The pipes, for example, let's say they are constructing these here, by the way, they are the underground drainage pipe, the stormwater drainage pipes, okay? So someone's saying, can you measure this segment of the pipes for me, because the pipes on site, they don't match the specified length that we have. For example, they called you back to the office, can you do that? You've got this plan here on paper, and let's say you've got, there's no scale specified here, but let's say that you've got a scale of 1 to 200, for example, okay, on this drawing. You've got a ruler with the scale, the only ruler you've got there with the scale of 1 to 100. That's the ruler you've got. You measured a length here, let's say that there, hopefully that will come up with a realistic number. Let's say that you've got there as, say, on your ruler, the number you read is 15. It's not 15 millimeters, it's 15 units. Let's go back, I'll show you this again so you can get a better idea. I'm not sure if you have one of those. You don't have to have them, but just so you understand, if you get to use them down the track. As you can see here, that is not a millimeter anymore. That's a unit for that particular scale. So that measurement here, it's not a millimeter. Okay? Each one of those is not 1 millimeter. It's a unit for that scale. So let's say that you measured on your ruler 15 units. Your ruler scale is 1 to 100, and your drawing scale is 1 to 200. So how do we work with this? As we agreed, let's go back here. We agreed, this is the rule here. We have to create, first of all, our scaling factor. Scaling factor is the scale of the ruler divided by the scale of the drawing. So let me get my calculator. The scale of the ruler, or the scale of the ruler at the top, which is 1 to 100, as we agreed, and the scale of the drawing is 1 to 200. Divided, that will give me my scaling factor, equals 2. I've got another example here. I'll talk about this example in a minute, but regardless, let's carry on with this example that I'm doing. By coincidence came the same scaling factor. This is my scaling factor. I measured on the drawings 15. So how much my length on site. So my length on site would be what I measured multiplied by the scaling factor, obviously, which is 15 times 2. I should call back and say it should be 30 meters. So the measurement on site is always in meters. That's for sure. The measurement you're reading, it depends on the scale that you are using. I will emphasize again, it's not in millimeters. It's the scale that you are using. This particular scale here does have units. I've got another example here. Saying if I'm using a ruler of 1 to 100 and to measure on the plan, okay, so okay, so saying here if I've got the ruler of 1 to 100 and the plan scale is 1 to 200, that means my scaling factor, as we said, will be equal to 2. In the above example, if we measure 80 meters on ground, so on site, that's the other way around. Now let's say someone will call you on site saying, look, we measured this to be 80 meters. Can you please just draw it on the plans, mark it on the plans, so we know if it's enough or we would be short. Will it be enough to get to the intersection, or will it be short? So you need to draw it on the plan. They gave you a measurements in meters and you need to draw it on the plans. So how do we do that? Always what you need to draw on the plans equal to the actual measurement, what they gave you, divided by the scaling factor. You calculated your scaling factor based on the two, on the scale of your ruler and the scale of the drawing, and that will give you, and the actual measurement is 80 divided by 2, that will give you 40 units. Using that ruler, you measure 40 units on that ruler and you draw a line, and that will show you where that line will end, so you can call them and say it's enough or not enough, for example. Okay, so it's important to know that, important to know how to work with this manually. I know most things are on the computer these days, but still there are many cases. There is always cases where you need, if you are on site, for example, and you're doing an inspection, someone will ask you a question and you need to draw on the plans, mark it on the plans. You need to draw it accurately. We need to know how to use this. All what you have to do, just the ruler over the plan. That's how you do it, isn't it? We put the ruler on top of the plan when we measure. So always the ruler on top, the ruler scale on top, what you are using, divided by the scale of the plans. That's number one. That will give you your scaling factor. Your length on the drawing is always smaller than actual length. Therefore, the length of the drawing always equal to the actual length divided by the scaling factor, which is all the time, or most of the times, will be more than 1. Okay? So I'll keep in mind the length on drawings is always smaller than the length on the ground. That's all in civil engineering. I'm talking about civil engineering. In some other engineering, like mechanical engineering, could be the other way around, or electronics engineering, where they've got very small components and they draw large drawings for these small components. In civil engineering, we do it the other way around. We've got usually large components and we need to draw them smaller on the plans for the road design, for example. Please practice this. That will be part of your quiz to know how to use that. It's important to understand how to use rulers, especially if you're on site, you don't have computer, you don't have the access for a computer. That will help you to use those. Now, how do we do this on Civil 3D or AutoCAD? Obviously, anything on the computer software that will give us much higher accuracy. So let's start Civil 3D. And let's take a few examples to see how we can use them there. I will show you why Civil 3D is starting, so that will be part of your tutorial. So if I look at your tutorial here, what I gave you there, various readings of measurement. I'm telling you the drawing scale, so this is distance at 1 to 20, that means this is the plan scale. If you are measuring on a plan, you've got a plan and you're measuring on that plan, this measurement in this instant, for example, let's do the first one for you. So in this instant here, I've got the actual measurement. I'm reading 60, that's 65, so that's 62 of a scale 1 to 1. Let's do, let's do the one underneath, 620 for a scale of 1 to 10. And the measurement, the plan scale is 1 to 20, as we agreed. Always the ruler over the plan. So the first thing, the scale factor, let's call it, equals to the ruler, which is 1 to 10, divided on 1 to 20. That will give me the scale factor. So doing that, so we don't make mistakes. 1 on 10. 1 on 20, and that gave us again 2. That's our scaling factor. As we agreed, the length on the plan will be smaller than the length on the drawing. So the length of what I need now to obtain here, what's the actual length on the drawing? So the actual length would be, so L actual equal to, as we agreed, what I measured here, which is 620 times the scaling factor, and that will give us, should be 1240, I guess. 1240. So that will be 1240 meters on site. Okay. And I've got the solutions for you here for this tutorial. So the purpose of this, so you can practice. That's 1240 for the first one. Okay. The whole purpose of this, guys, just so you can practice and you learn how to do them correctly. It's important for us to understand how to do this. I've got different rulers here with different scales, and I've got different measurements that you're taking on a plans with different scales. So this number here is the plan scale. On the second page, I'm saying the other way around now. If I will give you an actual length on site, and I gave you the plan that you are drawing, you need to show this measurement. Let's say it's for a pipe I've got here, for a stormwater pipe. This is the plan that you are drawing that pipe on, the scale of the plan, and this is the scale of the ruler that you are using. Obviously, the number here, first of all, always the scale ruler divided by the scale of the plan, and the number here would be smaller, so that divided by wherever you get from these two. So let's do one of those quickly, so without writing it down. So the scaling factor, again, I've got 1 on 100 and 100 divided by 1 on 5,000. That's 50, and my measurement on the drawing would be smaller, so I have to divide by that. So 630 divided by 50, and that will give us our answer, which is 12.6. Again, you've got the answers for those two, and that's the first one, 12.6 meters. Okay. Sorry, that's 12.6 units. That's important. So this is definitely in meters, but this is 12.6 units of your scale, what you are using, okay? Of that ruler, what you are using. I'll remind you again, going back here, these rulers, not all the time, each one of those is a millimeter. It's a unit for that particular scale. Great. So, Civil 3D. We are, as you can see, Civil 3D, lots of similarities with AutoCAD. So if we were to scale a plan on Civil 3D or AutoCAD, it would be the same. So let's have the same example of someone is calling you on site, asking you for a measurement of that pipe or for a different pipe. Definitely we'll get much more accurate information from doing it on the software, but as we agreed, not all the time you have the access for software, especially if you're on site. So how do we do that? First of all, I need to insert that PDF into the drawing here. Before I do all of that, very important, make sure, check your units. You enter, and that will show you your units. Our units in meters for civil work, all what we use is meters. Not like structural design, we use millimeters. In civil work, our main unit for length is meters. The angles in degrees, minutes, and seconds. This is our second discussion today about the bearing. Bearing is measured degrees, minutes, and seconds. And the resolution, we go all the way down to each 1 second, the required resolution. Our bearing direction is clockwise. That's one of the points that we'll be discussing today. And our base direction is north. Always we have north is our 0, and that's where we start our bearing. We will talk about this in a minute. The important point that we know, our main starting point, or the base angle is north. That's our 0 for measuring angles. And I'll go OK. Okay. There we go. So we've got this information sorted. Now let's say I've got that PDF. How to insert a PDF into AutoCAD. We'll go to Insert, or you can go from here, Insert, and Import. Okay. This is especially on the new versions of AutoCAD and Civil 3D that will import it into lines and polylines. We didn't have that capability before. It's a great feature, so I take advantage of it, guys. So looking here, I downloaded that Rodent section sheet I've got online. I'll just select that, which is you can download it and go find it in your downloads and select. It's asking you here about the scale. What scale do you want? We don't know yet, because that's the point of all of this. We need to scale it correctly and giving us some information. Really not too much of an importance to us. Let's just import this, okay? Asking me where do you want to insert it. I'll insert it in this point here. As you can see, AutoCAD or Civil 3D is inserting that. As you can see, the bar at the bottom here. Perfect, we've got it. So that's the drawing here, okay? Now, if I measure anything here, for example, let's say they ask us about this pipe from, let's say, from this point here. Let's say they're asking about from this point here all the way to that point, intersection point there. Okay, let's say this is what they're asking us, the red part. First of all, as you can see, now the PDF here turned into lines and polylines, so you can work with them, which is a great feature. So that will help you a lot down the track when you work, hopefully down the track when you work with consulting offices. That will allow you to import PDF layouts from the architect or from anyone who've done the previous stages on the design, so you can work with them on AutoCAD or Civil 3D. There we go, going back. So this is the portion that we're trying to measure. But if I measure now, this will not be accurate because I don't know what scale I imported this drawing, and I have no idea the accuracy of that scale. What I've got here, I've got the scale bar. The minute I have that scale bar, that will be a great starting point. So what I need to do is scale it correctly. I select the drawing and I go to scale. And I scale from any point you would like. I usually go to the point where the scale is. This is the point, the pace point for scaling. As you can see, the more I'm stretching the line, it's scaling it up or down, okay? But that's not, again, that's not the right way to do it. So what should I do? I should enter, as you can see here, it's giving you an option for reference. So if I press R, enter, ask me what's your reference. I'll say I want from this point to that point. Here it's completely horizontal, but just to make sure, I prefer always to click on the ortho to make sure I'm on the horizontal. So from that point again to this point here, and I know this measurement here should be 10 meters, so I enter just 10. Here we go. Now if I measure, go back here and measure that length, that should give me accurately 10 meters, as you can see, with high accuracy. Let me undo this to show you the length before we scaled it. That's the drawing, I think, before we scaled it. So let's measure that length. It's 0.7, so 780 millimeters, 0.78 of a meter. So you can, if you'd like, measure that length and you want this to be 10, create the ratio between the two. That's what I used to do the old days, but then the feature came on AutoCAD and Civil 3D that we can enter a reference, which is easier. All what we have to do is select this drawing. Again, I will do it. So I will go to scale under the home button, and I usually scale from this point here. Zoom in so you can make sure you got to the right point, and asking me for the scale reference, I'll put R to enter the reference, enter, and I say from this point to that point I want it to be 10 meters. and that's again 10 meters, as you can see. Okay, now if I did that, that means everything here is to scale correctly. In other words, if they were asking me, that takes obviously a few seconds when you are good at it. So again, if I go back here to measure that pipe length, choose the line length, and I go, let's say they ask me from center of that intersection to the center of that intersection here, roughly to here, and that will give us about 60 meters. Okay, so there you have it. This is how we scale things on scale plans on Civil 3D or AutoCAD. Now, not all the time you've got these plans in PDF. This is very important, guys. This will be your step number one for almost lots of work that you have to do, especially if you don't have CAD layouts. In lots of our designs, we share PDF layouts, okay? Not all the times you get the CAD layout. So this is a very important step to scale our drawings correctly. Not all the times we're working with PDFs too. For example, let's take another example. If we were looking at these subdivisions and I need to measure the width of that road here, for example. So let me just choose a better location, refresh that. This is the map view. I usually use this map view. It has a clearer view comparing to Google Maps. Obviously, we don't use Google Maps at work. We use better even viewers, but for now this is a free version that you can use personally. So let's take an example, the TAFE campus at Regency, for example. So if I zoom into, this is the intersection between Regency Road and Days Road. This is where TAFE is. Okay, so this is, you can go to SA Property and Planning Atlas. So if you search for that, you should be able to find this easily. Okay, that's the website there. So if I show the actual buildings, which is, by the way, very useful tool. I use it a lot. This here, not all the time we insert PDFs into Civil 3D or AutoCAD. There's many times that we use, we insert images. For example, let's say we've got the inquiry. We are consulting engineers, civil engineers. We got the inquiry to design the site drainage, the stormwater drainage for this car park area, for example. Okay, and we sent our surveyors, or an order for our surveyors to go there and start surveying the car park. This may not happen before a couple of weeks time, for example. Until then, what we can do, and that's what we usually do, we use this a lot for preliminary design, for initial estimation. Okay, not for the highest accuracy. Obviously, when we need things to be much more accurate, we send our surveyors and they get us the information correctly. We can get DWG layouts for that entire area. But for now, as a starting point, for me to be able to draw this on AutoCAD or Civil 3D and I start my design, all I have to do, just let's say that I'm just interested about this area here, this car parks. Okay, so I'm zooming in to that area, and all I have to do is screenshot. So I'll take a screenshot of that, and you can use the snap tool on, if you'd like, if that's easier for you, the snapping tool on Windows. New snap, and I think that will allow us to snap from here. There we go. Important, very important, guys, that you go to that corner there. Can you see the corner here at the bottom? Okay, where I've got the scale. It's very important to get a scale. Without the scale, we can't do nothing with it. So let's say I've got that. Let's save this view as a JPEG file. I'll save it just under the course material. You can save it wherever you want. Let's call it TAFE car park. Okay, saved it. Now how can we import this into Civil 3D? Let's delete that, we don't need it anymore. The same thing, I'll go to insert, the insert tab. This time, instead of going to import, I'll go to attach. And that will allow me to attach an image to my file. It's navigate to the location of the photo. If not, you can navigate to it, and anyway find the image that you took, the screenshot of the car park you took, and say just insert anywhere. You're asking for the scale. As we agreed, we don't worry too much about the scale initially, we will fix it in a minute. So I'll just enter 200 for now, so I can just place it anywhere. Now this is where we do exactly the same thing. So we'll go to home, scale, scale this item, select the object, enter, asking me what's your base point. I can scale from any point, doesn't matter. How much your scaling factor? I would say reference R, enter, and I'll zoom in as much as I can, and to be more accurate, I'll go into the center of that black line. That's where I said it's better to click the ortho, keep the ortho on, so you take a complete horizontal length there, and I'll zoom in as much as I can to the center of this line here. I'm saying this measurement here, I want it to be 6 meters. So I will enter 6, enter. Let's check the measurement. If I measure, always check after you do it, please. So if I measure from the center of this point of this line to the center of that line here, should be around, that's it, 596. So it's about 6 meters. Why this is important to us? Because now I can draw this car park easily as an initial layout. Turn off that, and quickly as a quick accurate sketch. So this is a preliminary design, as we agreed. It's not the final design, a preliminary design here, but still it's accurate enough to give us very important information. By doing that, I can measure the length of any of those sides, I can measure the area, I can do all of these inquiries that we need to, or we usually do for civil design. Okay, if anyone, for example, we're looking at this road design, I can easily measure this road width from here to there. For example, it's about 6.8 or 6.9 meters. Okay, next time you go to TAFE, check that measurement for us and see how accurate our information. You'll find it very accurate, impressively accurate as an initial design, especially that didn't take you long at all to get it done. So that's how we do the opposite. How do we measure things on site using the software, and we scale things correctly, scale drawings as a PDF or a aerial view of the site, and we utilize it for our design as a starting point. Okay, now I'm not going to give you an exercise on this one. You've got the PDF. To try the image one, you can choose any site that you are familiar with. You can view your home on this viewer and measure one of the boundaries, or measure the width of the road in front of your house, and go outside and measure it, check it yourself, and see how accurate your measurement is. Okay, this is a very important tool that we learn, guys. We will need it. You'll see that we will need it down the track when we start talking about subdivisions. If I need to enter the area view of the land, for example, let me give you an example. This area here, to my knowledge, it's newly subdivided into new allotments of residential blocks. So usually we need to understand the constraints about the entry and exit here around the roads. When we start designing the roads for the area here, if there's any existing structures or infrastructures on site, if there's any existing trees. So it's very important that we scale this area view into our drawing. Very important tool we need to be familiar with. Okay, all right guys, this is it for this video. I'll start a new video in a minute talking about bearing and the rest of our information for the drafting techniques. Thank you.